Welcome to the Deep Dive. We unpack stacks of sources to get you basically up to speed fast on big ideas. Today, we're looking at space habitats, but maybe not the ones you're thinking of. Forget the usual cylinders, the domes orbiting planets. We want to explore something, well, much more fundamental. What if we could design with gravity itself? Not fight it. What if you could actually, sculpt space?
Shape it into somewhere livable.
Exactly. So this deep dive is into gravity shells.
These are theoretical megastructures, really theoretical.
Build right into the curvature of space-time. We'll get into the physics, the possibilities, what it might mean to actually live in engineered dimensions.
Yeah, the implications are pretty mind-bending.
Our mission, like always, is to pull out the key stuff from the sources we've looked at, give you a shortcut to understanding this really advanced speculative field.
It is breathtaking stuff when you get into it.
Okay, so let's unpack this, because to really get gravity shells, we need to back up a bit.
Yeah, you have to start with Einstein. General relativity, 1915.
Right. Because for ages, gravity was just seen as this force, right, a pull. But Einstein, well, he turned that completely on its head.
He really did. What's fascinating, and our sources really emphasize this, is Einstein saying gravity isn't a force at all.
Not a force. So what is it?
It's curvature, a warping of space-time itself. You know the classic analogy.
The bowling ball on the rubber sheet.
Exactly. The heavy ball makes a dip. A marble rolling nearby follows the curve in the sheet. It doesn't get pulled directly by the ball.
Ah, okay. So massive things warp space, and other things just follow the curves. Planets, light.
Even time. It affects the flow of time, too.
So wait, gravity is geometry.
In essence, yes. It's the geometry of space-time, and that's the key insight.
Because if it's geometry...
Then you can think about working with it, engineering into the curvature, not just, pushing against it.
Which is totally different from Newtonian thinking. It's relativistic architecture.
Precisely. Relativistic architecture is a great term for it. It's not about building in space anymore. It's potentially about building from space, using the fabric itself.
Building from space.
Yeah.
Wow. Okay, that changes everything. So if we're using space-time itself, what exactly is a gravity shell? How do we define that?
Well, at its core, a gravity shell is this proposed megastructure, right? And it actively uses or manipulates space-time curvature.
To make a stable place to live.
Exactly. To create an inhabitable environment by leveraging cosmic geometry. It's a whole different kind of engineering.
Okay. And the sources we looked at mentioned, three main ways this might work, each one kind of wilder than the last.
They generally fall into a few categories.
So first up, just using natural curves.
Yeah.
Like building things in places where gravity already balances out.
Right, like Lagrange points. Those spots where the gravity of, say, the Earth and Sun cancel out just right, you could build there.
Or maybe nested orbits around huge things like gas giants or stars, just being clever about placement.
Yeah, taking advantage of the existing gravitational landscape.
Okay, but then it gets really weird. Concept 2. Building artificial shells around super dense stuff.
Yeah, this is where it gets pretty extreme. We're talking about a shell around a neutron star, or maybe even a small black hole.
Whoa. And the gravity wouldn't come from spinning the habitat, like in, classic sci-fi stations.
No, that's the crucial difference. The gravity would come from the intense curvature caused by that central dense object. It's tapping into that immense gravity field directly, a fundamentally different way to get artificial gravity.
Okay, mine's slightly blown already. And the third concept, the most speculative one.
Space-time bubbles.
Bubbles, like little pockets of reality.
Sort of. The idea is creating these localized bubbles, regions of space-time where you could maybe engineer the curvature, control gravity, maybe even control the flow of time locally.
Control time. That sounds like, that's straight out of fiction.
It does, but the thinking behind it, it's inspired by actual theoretical physics. Like Miguel Alcubierre's work on the warp drive metric back in '94. That explored manipulating space-time geometry, too.
So there's some basis for it, even if it's way out there.
There is. And to make it feel a bit less abstract, some sources mention specific models, like Adam Crowell's shell world idea from 2010.
Shell world, what's that?
He envisioned layers, like planetary rings almost, forming huge habitats, multi-level structures supported by orbital tethers or maybe playing with gravitational gradients. It's a way to conceptualize layering habitats within these fields.
So it gives kind of structure to the idea.
Exactly. And while, yes, a lot of this is hypothetical, it's important to stress the underlying math. It's grounded in modern physics, general relativity. We're not talking magic spells here.
Right. The principles are sound, even if the engineering is Well, let's get into that.
Mhm.
If the math checks out, what does it actually take to build these? Let's shift from the what if to the how on earth. The engineering challenges must be insane.
Oh, they're astronomical. Almost literally. First off, materials. You need stuff with unbelievable tensile strength far beyond anything we have now.
Like what kind of materials are we even talking about?
Sources mention things like carbon nanotubes, graphene, maybe theoretical materials like diamondoid structures, things that can withstand incredible stresses.
And it's not just about being strong, right? It sounds like you'd need mind-boggling precision.
Absolutely. You'd need incredibly precise gravitational modeling. We're talking complex relativistic simulations.
To predict what? What could go wrong?
Well, things like tidal forces, the stretching and squeezing from gravity, and time dilation affects time literally running at different speeds in different parts of the shell. You have to model all that just to keep the thing dynamically stable.
In this incredibly complex, shifting gravitational field.
Exactly. And then there's energy. The power requirements are just immense.
What kind of power sources? Solar panels aren't going to cut it, I guess.
Not even close. You'd need exotic sources, huge fusion reactors, maybe antimatter containment if we ever figure that out, or even tapping into quantum vacuum energy for the really fine-tuned adjustments to curvature.
Wow. Okay. Harnessing fundamental forces.
Hmm.
I read about Robert Forward's idea, too, from 1990, using rotating rings. Something about frame dragging. It's a real thing, right?
It is, yeah. Frame dragging is a real prediction from general relativity. It's this subtle effect where a big rotating object actually drags space-time around with it.
Like stirring honey?
Kind of like that, yeah.
Yeah.
And Ford theorized you could potentially harness that effect with rotating mass rings to create artificial gravity.
See, that shows these aren't just wild guesses. They're extrapolations of known physics.
Exactly. Now the costs, unimaginable, but the potential benefits, also unimaginable.
Like what? What's the payoff for this colossal effort?
Fully controlled gravity environments. Imagine setting the gravity level you want. Plus, maybe using space-time layers for radiation shielding. And these variable time zones, think about specialized computing or maybe medical treatments.
So it's not just a place to live, it's a machine.
My gravitational machine, precisely. That's
Yeah.
a great way to put it.
A gravitational machine. I like that. So what's the single biggest advantage this machine has over, say, a spinning O'Neill cylinder?
I think it really is the control over gravity itself, not just mimicking Earth gravity with spin, but actually dialing gravity up or down, maybe having different zones. Imagine a hospital wing with lower gravity for recovery or high G for training.
That level of environmental mastery
Where?
is transformative.
It really is.
Hmm.
Which brings us to the next big question. What would it feel like? Living inside curved dimensions, how do you even picture home then?
Yeah, that's the crux of it.
Yeah.
Imagine a world where up isn't just up. It's defined by the curve of space around you.
The sources try to paint a picture.
Rivers flowing in spirals, maybe?
Yeah.
Following the local gravity contours. Cities stacked vertically, but not just floors in a building. Actual layers in a dimensional gradient, each with slightly different gravity.
And the time thing, that's still the one that gets me. Having slow zones for, I don't know, research or just quiet contemplation.
Or fast zones for super intense computation or work. You could literally live time at different rates depending on where you are in the habitat.
The impact on society, on just how we perceive life and work. It's hard to fathom. Imagine choosing your personal timeline.
It's staggering.
Yeah.
Which raises a huge question, right? How does that change us, our biology, our psychology? We evolved for 1G, one rate of time.
It would be a massive adaptation, no question. A profound challenge.
But also, maybe, profound freedom. A step towards being truly post-planetary beings,
Yeah.
not tied to the conditions of one world.
It definitely forces us to reconsider what it means to be human, how we structure society when the basic environmental constants aren't constant.
And philosophically, wow, what does home even mean anymore? It's not a planet, not soil, not even a spinning can, but a sculpture made of space-time itself.
A living architecture defined by geometry. It's a really profound concept, an act of creation on an unbelievable scale.
So as we push out to the stars, maybe the idea isn't just building in space.
But learning to build with space,
Yeah.
using its fundamental properties.
Gravity shells, then. They feel like the ultimate expression of that. Dynamic, curved, responsive, maybe even beautiful.
Absolutely. The ultimate in relativistic architecture, a completely new paradigm for habitats.
Maybe one day, yeah. Our cities orbiting black holes, our homes floating on engineered space-time, and people looking back and saying, that's when they really learned to shape gravity, like clay.
It's a powerful vision of the future.
So the final thought to leave you with. How does our whole understanding of existence change when our homes are literally made of space-time? What becomes possible if we truly master the geometry of the cosmos?
Definitely something to ponder.
Stay grounded,
Yep.
even if space itself is bending all around you.